All right, so 7-6 was inverses, showing if two inverses or two matrices were the inverse of each other, where you had to do the work to get that pattern, the 1, 0, 0, 1, or finding the inverse like this one. So I'm going to do the shortcut on this because we're going to do the long one when it gets to the next one. Okay, but the shortcut was to find the determinant, which is that product of -3 times 1, so -3 times 1, minus 2 times -2, and you get -3 plus 4, which is 1. And then that goes under 1, which in this case doesn't have an impact because it's just 1, but if it was any other number, obviously it would. It goes under 1 on the outside of the modified matrix. How do I modify it? Switch the -3 and the 1 and change the sign on the other two. So the -2 becomes +2 and 2 becomes -2. So this would be the result. -3, 2, -2, 1. Easy stuff, right? Everybody good on that? I have just seen people switch the wrong ones or change the sign on the wrong ones on the inside. Be careful, okay? All right, then we get to a 3 by 3, which has to go the long way around. So our goal here is to make the left side of this equation become 1, 0, 0, 0, 1, 0, 0, 0, 1. So we have to make changes to the left, and in doing so, we'll change what's on the right and then end up with our inverse. So if I wanted to get a 0 in this location, how could I do that?
Multiply the bottom by 3 and then add it to the second.
Okay, 3 row 3 plus row 2. So -3, 12, not negative, -12, -21, 0, 0, and 3. And then add that to row 2, which is 3, 7, 9, 0, 1, 0. I get 0, -5, -12, 0, 1, 3. And then that's going to take the place of row 2. So 1, 2, 2, 1, 0, 0, 0, -5, -12, 0, 1, 3, -1, -4, -7, 0, 0, 1. Now I want a 0 in this location. How could I get that? Add row 1 and row 2. So if I do that, I get 0, -2, -5, 1, 0, 1. And that's going to take the place of row 3. So this would be 1, 2, 2, 1, 0, 0, 0, -5, -12, 0, 1, 3. Now I want a 0 in this location. How could I do that? What would happen if I add 1 and 3 though? The 0 goes away. So therein lies the catch, right? When you get that last 0 on the bottom, you have to use row 2 and row 1. So if I multiply row 2 by, let's say, -2 and row 3 by 5, so this is -2 row 2 plus 5 row 3, I get 0, 10, 24, 0, -2, -6, plus 0, -10, -25, 5, 0, 5. 0, 0, -1, 5, -2, -1. And that is my new row 3. So 1, 2, 2, 1, 0, 0. 0, -5, -12, 0, 1, 3, and 0, 0, -1, 5, -2, -1. Okay, now I want a positive 1 here, so I can actually change the signs on everything that's there by multiplying by a -1. That's the first thing I could do, okay? But I also have to work my way up. I want a 0 here. How do I get a 0 where that -12 is? Bottom by 12. So 12 times row 3 plus row 2. And I'd get 0, 0. This is a positive 1, so this is a 12. That's a -5, -60. Positive 2, 24. Positive 1, 12. Plus row 2. I need a 0 here. How do I get that?
Multiply the last one by -2 and then add it to the top.
Good. -2, row 3 plus row 1. That replaces row 1. And I'm also going to multiply row 2 times a -1/5 to get that to be a 1 in the same process. So this would be 12, 5, -5, -3. Oh my goodness, I didn't rewrite the new row. This is the new row 1. 1, 2, 0, 11. One last 0 here. How do I get that?
Add the second one. I mean, multiply the second one by -2 and then add it to the first.
Good. And there's my new matrix. This side is in the pattern I need it to be, which means this right side, -13, 6, 4, 12, -5, -3, -5, 2, and 1 would be the inverse of that initial matrix. So maybe you did it a different method, which is fine, as long as your answer is the same. There should be no rearrange of an order on this one. This should be exactly the way that it is. And again, you can check this in your graphing calculator. Remember, just put in the matrix in the beginning and then do the a to the -1. Questions on that one? Okay. So in this section, we're going to do 4 things, really. Determinant of a 2 by 2, minor and cofactor, and then determinant of a 3 by 3. So the 2 by 2 is what we talked about yesterday, where if I wanted to find the determinant of this matrices, I would multiply the A times the B and then subtract from it the A times the A2 times the B1. And then the only thing other thing that's important on here that we haven't talked about yet is how you would note a determinant. So notice that these change to like absolute value bars. Those absolute value bars mean find the determinant of what's inside. So if I gave you something like this is not just a matrix. This is saying find the determinant of that matrix. So the difference is here with the bars, now it's just a matrix. Without them, those solid absolute value looking bars is telling you to find the determinant of what's inside. So hopefully these we can do quickly because we talked about this yesterday. So if I'm finding the value of the determinant, then I'm multiplying 1 times -2 and then subtracting 5 times 3, -2 minus 15, which is -17. And then B, same thing, -1 times -3 minus 4 times 2. So 3 minus 8, which is -5. What we didn't do yesterday, that we'll do today, is I show you how to use your graphing calculator to find the determinant.
What was the answer for the second one?
-5. You're welcome. Where's my camera? There it is. All right, so what I'm going to do is go back to my graphing calculator. I go back to the matrix menu. This one I'm going to do B. So B is a 2 by 2. I'm going to go to edit. I already have a 2 by 2 in B. So I would make it a 2 by 2 if it wasn't already, and then I would enter them in, -3, 2, 4, -1. And then go back to my home screen. So I've just entered in my 2 by 2 matrix. Again, I'm doing B, but you could do either one because you can check either answer. And then I need to go back to my matrix math menu. So I go second matrix, I go to math, and DET is the first one in the row. And then bring up the name of the matrix you just used, which in my case was B. Hit enter, and there's the -5, which is what we got. It's in the matrix menu under the math. So second matrix, and then go to math. It's the first one. So you can do this with a 2 by 2 or a 3 by 3, which we're going to eventually talk about. Super easy way to check. Everybody good? Everybody able to find it? Yep. So now you can check all your answers in your homework. All right, the next part is called minors and cofactors. So a minor is found for each individual entry of a matrix. So if I have a 2 by 2, there are 4 minors, 1 for each location. If it's a 3 by 3, there are 9 minors, 1 for each location. The 2 by 2 is really easy. All you do is cross through the row and the column of the spot you're looking for, and what's left is your minor. So if I had a 1, 2, 3, 4, and I wanted to find the minor of row 1, column 1, then I literally cross through row 1 and column 1, and what's left is the minor. And I would continue to do that as I go through all 4 places. With a 3 by 3, so if I add on to this, then when I go to find the minor, I'm going to do the same thing. If I want to find the minor in the first location, I'm going to cross through that row and that column. But I have 4 cells left, and I'm going to take the determinant of those 4 cells, and that's what the minor is for that location. Then I'd go to the next one, cross through the row and the column it's in. 4 different numbers will be left. I will find the determinant of them, and that would be the minor for that location. Once you find all your minors, you can find the cofactors by simply changing the signs on specific locations. So if it is a 2 by 2 minor, then I change the sign in the top right and the bottom left numbers. The other 2 I leave alone. If it's a 3 by 3, then I change the signs of the locations that would be like your north, south, east, west locations. Those 4 numbers you would change the signs on, and then the rest stay as they are. All right, we're going to work through an example. So we'll start with the minors of a 2 by 2, and then we'll move on to the cofactors. So if it's a 2 by 2, then again, I am getting a 2 by 2. This one is row 1, column 1, which is the 2 things I cross out. Row 1 and column 1, and what's left is -6. That's the answer that goes there. Then the next one is row 1, column 2. Cross those out, and what's left is 3. Then I go to the next one, which is now row 2, column 1, and I get 5. And then I go to the next one, which is row 2, column 2, and I get 4. So on a 2 by 2, they're really only switching corners. So these are the minors. This is A. And then B, all I have to do is change the signs on which 2? Three and 5. So -6 stays -6, 3 becomes a -3, 5 becomes a -5, and 4 becomes a +4, or stays a +4.
6 doesn't become positive?
Nope, you don't change the signs on the top left, bottom right, just the top right, bottom left.
When are you changing the signs?
When you're finding the cofactor.
Whereas mine just leaves the same.
Minor stays, yeah, minor stays the same. Yep.
There's always going to be one number.
For a 2 by 2. So now we're going to do a 3 by 3. Yep. So the initial process, the cross through stays the same. That's why I wanted to keep it that instead of just telling you to switch. The process starts the same, but then you have to find the determinant of each of the ones that follow. So because this is a 3 by 3, I know I am resulting in a 3 by 3. So your tic-tac-toe board. So the first cell we're filling is called what? What's the location of that first cell? Row 1, column 1. So your book will note it as the minor of 1, 1. That is row 1, column 1. This time you're going to have to do a little bit of work to fill that space. So in minor of row 1, column 1 means I cross through those two things, row 1 and column 1. And I find the determinant of what is left. 2, 1, negative 1, 1. I'm going to go back and do that work, but I'm going to continue in the pattern of going to minor of row 1, column 2. So now instead of doing row 1, column 1, I'm doing row 1, column 2. I'd find the determinant of negative 3, 1, 1, 1. So you put the numbers in the order in which they appear. And then I'm going to find the determinant of that. And then I'm going to go row 1, column 3. So this time, row 1, column 3. And I find the determinant of what's left. Negative 3, 2, 1, negative 1. So from each one of those little boxes, we have to do the fish. So 1 times 2, which is 2, minus negative 1 times 1, which is a negative 1. 1 plus 2 is 3. 1 times negative 3, minus 1, negative 4. Negative 1 times negative 3, minus 2, 1. And that fills my first row. 3, negative 4, 1. With me so far? Now I do row 2. So now it's 2, 1, 2, 2, and 2, 3. Yep.
The determinants, you leave them as whole numbers or one over the determinant?
No, you leave them as whole numbers. So the determinant itself is just what was in the bottom. We only put it as 1 over to find the inverse.
Oh, okay.
So now I'm in row 2, column 1. What's left is 0, 2, negative 1, 1. And then I move on to row 2, column 2. What's left is 4, 2, 1, 1. And then I move on to row 2, column 3. And what's left is 4, 0, 1, negative 1. And then I find the determinant of each of those. So 0 minus a negative 2 becomes plus 2, or 2. 4 minus 2 is 2. Negative 4 minus 0 is negative 4. And that fills row 2. Fun stuff, right? Yeah.
Why is it like
It's the minor row 1, column 1. That's how your homework, that's how your book does it. If you just want to go in order, if you wanted to make a big, tic-tac-toe board and fill each individual one with the determinant, I don't care how you do it, as long as you know what you're doing. And then minor row 3, so 3, 1, 3, 2, and 3, 3. So 3, 1 leaves me with 0, 2, 2, 1. 3, 2 leaves me with 4, 2, negative 3, 1. And 3, 3 leaves me with 4, 0, negative 3, 2. So this is 0 minus 4, which is negative 4. This is 4 minus a negative 6, which becomes plus 6. And this is 8 minus 0, which is 8. Negative 4, 10, 8. So just think of all the practice you're getting on your determinant. Questions on those? Yep.
So what exactly?
So this actually leads into another method of solving for the determinant, but I'm actually not going to teach you that method. I want you to know these terms, minor and cofactor, because you're going to see them again, especially in calc. You might be taught or forced to use this way to find the 3 by 3 determinant, but I'm going to teach you a different method because when I taught both, everybody chose the second anyway, so yeah. But I still have to do the cofactors. So the last part of this is the cofactors, right? The cofactors, I'm going to keep the same matrix that we just found, except I'm going to change the signs on which location? The north, south, east, west, right? So the 3 stays the 3, the -4 becomes a +4, the 1 stays a 1, the 2 becomes a -1, 2 in the middle stays the same, -4 becomes +4, -4 stays the same, -10, and then 8.
So you do switch like north and south, I guess.
You don't switch them, you change the signs on them.
Okay.
Yeah.
So if it starts negative, you
You make
change
it positive,
Okay.
exactly. Olivia.
Wouldn't the -4 in the second row be in the middle?
2, 3. I think that's right, right? You're saying this one, 2,
I think I wrote it wrong.
3, yeah. It's okay, I totally made a mistake in the first class. And it's so easy, right? Look at how many little steps there are, so just be really, really careful. So this is the cofactors, which is B. Questions? Isabella?
Can you go over which ones you have to switch in the cofactors?
It's the north, south, east, west locations. So the 4 that are there. It's the middle of each side, really. Yep. This is expanding by cofactors is the other method for finding a 3x3 determinant, which we are actually going to skip. Okay, when I have taught both methods, nobody picks this one. So why on earth do I have to waste your time or mine, right? So this is how you would do it. You actually have to find the determinant by using the individual parts. And it's a long process. Most of us, which if you'd like to study it, it's all right there. Feel free. Most people would pick what I'm going to show you. And as soon as I start it, most people are like, oh, I remember this. Okay? The first thing you have to do, oh, you have a question?
Yeah, we skipped example 4.
Yep. Oh, wait, example. So the first thing you have to do when you're finding the determinant of a 3x3 is to take the first 2 columns and rewrite them to the right of the last one. So I rewrite this, right, as soon as you see it. You know it. -2, oh, it's not that bad. -2, 1, 3, 1, -1, 1. So you rewrite the first 2 columns to the right of the third. And then think about the pattern in which we do the fish. The diagonal we multiply first goes in which direction? Top right, bottom left, or top left, bottom right?
Huh?
What?
When we do the determinant of a 2x2, the little fish thing, which diagonal do we do first? Top left, bottom right, top right, bottom left?
Top left,
Top left, bottom right. So that is the order in which we do these, okay? We do each diagonal from the top left to the bottom right, and we find the product of those 3 numbers. So this is when you thank the Lord for zeros. Yeah.
Yeah.
So -2 times -1 is 2 times 0 is 0. 1 times -2 is -2 times 3 is -6. 0 times 1 times 1 is 0. And then I add those 3 numbers. And then I go back the other way. And I multiply each of the numbers in those 3 diagonals. So 0 times -1 times 3 is 0. -2 times -2 is 4 times 1 is 4. 1 times 1 times 0 is 0. And I get 4. God bless you. Think back again to your 2x2 and that little fish. What do we subtract from what?
The -6 minus the 4.
Exactly. So the diagonals that go top left, bottom right goes first, which in this case is -6. And then we subtract from it the ones we come up and do again, which is the 4, and I get -10.
And that's your determinant.
That's the determinant, and you can plug that into your calculator, a 3x3 matrix, and then hit the determinant and hit the name of it, and it will give you the determinant.
For some reason, I remember never getting these right last year.
It's just so easy to make a mistake.
I would always like to subtract something.
And you guys are so smart. You like to do everything in your head. You don't like to write anything out. And then you make mistakes. Yep. So you do all of these. You take what you got from all of these diagonals and then subtract from it what you got from these diagonals. So just like the fish, you go the bottom right, top left, those diagonals first, and then subtract from it the other ones. Carlos.
This is what we were doing yesterday, but like just a different way.
Well, we didn't do a 3 by 3 yesterday. No, yesterday we were finding the inverse of a 3 by 3. That's different. Yes.
So this is different from what we just did, right?
It's another method to doing it, and it's way easier. Okay. Do the last one, and then we're done.
This will be on our quiz, correct?
Yes. You're welcome. Mm-hmm.
Will we have a regular scientific calculator on the quiz?
Probably not. Yep.
Why do you rewrite only the first two columns?
Because you only need to form a diagonal of 3.
But why can't you do the last two?
Because then you'd have, oh, it's just the wrong combination of numbers. So it's like a trick that works with a combination of numbers. What you're really doing every time is eliminating the numbers that you would be eliminating if you're doing the minors. It's just a different way to eliminate them.
But when you put it into the calculator, you put it regularly and then you do.
Yep, you do a 3 by 3, you type in those 3, and then you go back to that math menu, you click the DET, you pull up the name of your 3 by 3 matrix, you hit enter, and it's going to give you the answer.
But we just did something else with determinant before.
We just did a 2 by 2. So the 2 by 2 is the fish. The 3 by 3 is where you have to do this. So
The
it's like an
fish was
extended
that-
fish. The fish is, I just call it the fish, but it's a determinant for only a 2 by 2.
And what was the one where we canceled and canceled? and-
Those are minors and then leads into cofactors. So you can use minors and cofactors to get a determinant. It's just a longer process.
Because then you'd get that, then you have to do the
You have
fish.
to multiply it times what's left. Yeah.
So if you ask for the minors, it's cross this, cross that,
Correct.
this. But if you ask for the determinant, you
It's
have to
this.
add.
Yeah. The determinant should be one number where a minor is going to be a matrix.
Thank you.
You're welcome.
The quiz on Monday
Correct.
for 7.7, we'll just include the minor
Yep.
thing in this.
And then determinant. So you'll get determinant and that. Yep. So 7.5 was your adding, subtracting, multiplying. 7.6 is your inverses, and 7.7 is determinants, minors, and cofactors.